I will now hand over to Jyoti, who will be talking about more about Gina and the event, the session, and everything about how we'll be going, how the workshop will be conducted, and at the end she'll share about the swag also. Jyoti, over to you.
Thank you. So, hey guys, I'm Jyoti, but you can call me Joe because chances are I don't respond to my real name. So, yeah, there's that. So, I currently work with the DevRel team at Gina. And so, Gina AI is the name of the company, and Gina is the project under it. So, we also have like Docker, we also have Finetuner. But today, specifically for this workshop, we'll be using Gina. And the main thing that you're going to like about it is that even if you are you're a beginner in AI or you're a beginner in data science, you are still going to enjoy it because Gina provides a level of abstraction that enables even beginners to use it in their projects. And about swags, yes, there is a swag form that we'll be sharing with you at the end of this workshop. And we also will be sharing the links to the collab repository, sorry, Google Collab notebook, where the code is written. So it would be great for you to follow along the notebook so that you understand everything. And we do expect you all to understand beginner to intermediate Python, because every code we write is in Python, of course. So yeah, that's all about it. And thank you for joining in. And I really, really appreciate this collaboration because Women Who Code have been like my favorite community for women in tech till now. And as Runjhun showed, the numbers are great. Everything is great about this community. So Alex is the DevRel lead, and he will be guiding you through this workshop, explaining you the code, explaining you how it all works. So over to you, Alex.
Alex, you're on mute, I think.
Sorry.
I'm sorry.
Total newbie error. Thanks for the great intro, Joe and Runjhun. It's great to be here. Always happy to speak about cool stuff to cool people. So yeah, I'm Alex CG. CG because my real name is too long, and like Joe, I barely respond to it anymore. And yeah, I'm the DevRel lead at Gina AI. So if you're not familiar with DevRel, the way I generally explain it is that the engineers do all the cool engineering work, and then we make it look stunning and glamorous, so developers around the world want to use our stuff. That's it in a nutshell. Yeah, if you want to know more about me, you can follow me on Twitter at AlexCG, ALEXCG. I tweet about tech, I smack talk NFTs a lot, and I swear a bit, so just bear that in mind. Not always safe for work. All right, without further ado, I'll start my little presentation about Gina and cute animals, and then we'll go to the meme search notebook, and I'll teach you how to write a search engine for memes. All right. Oh, hang on. Let me just share one window. Cool. Yep. For reference, that's my Twitter if anyone wants to follow me, ALEXCG. That's the best way to contact me. I don't really use LinkedIn because I don't own a suit. Right. So, yep. Let's get this party started. Okay. So yeah, quick content warning for everyone. There are going to be some cute animals ahead and not so cute ones as well. So if you don't like uncute animals, or if you don't like cute animals for some reason, just bear that in mind. So today we're talking about neural search, what it is, how it works, yada, yada, yada. But before we do that, let's think about what search is in itself. So to most people, when they think of search, they think of a text box like Twitter or LinkedIn or Stack Overflow or Bing or DuckDuckGo, or there's this other search engine that slips my mind. But you get the idea. That's what most people think. But really, search is about much more than that. Every time you use a chatbot, it's performing a search operation, finding an answer to your question out of its data set, and then returning one answer to you instead of like hundreds as Google would. Or imagine a scenario where you have a huge library of PDFs about, say, machine learning. And then you take one PDF of that and you want to find similar ones. So that's another kind of search. You could think of it like a similarity search. You've got thing A and you want to find similar things B, C, D, and E. Things like Shazam, again, you're taking something and you're finding something similar. A snippet of a Beyonce song and finding put a ring on it. Same, you can do the same with video search, same with visual search. Upload a picture of your favorite sneakers, get sneakers back. Someone really needs to build that into the next Amazon. And gee, I wonder if there's a framework that could do that. So yeah, that's search. You get the picture of what I'm talking about now. Upload something, find something similar. So neural search is all about using AI to do that. Artificial intelligence, or well, that's a bit of a buzzwordy rubbish term. So deep learning, machine learning. I promised cute animals. So these cute animals will help explain how a deep learning model does what it does. So yeah, we can start by looking at some pictures. I mean, and what can we tell from these? They're all really cute, and there are dogs and there are cats. And that's all the information that I'm getting out of it. So based on this information, we can draw a graph based on the cattiness or dogginess of the kitties and puppies. And I promised you on cute animals, here they are. And these are, believe it or not, 2 cats and 2 dogs. The one on the bottom right, is pushing the definition of canine a bit, but hey. So now where would we add these data points on our graph? I mean, we could still just use one line, but then we'd be missing a lot of information, I think. So we can add another axis, depending on how or these animals are. So now we've got basically 2 dimensions on the graph, 2 axes, and a series of points. I moved these around a little bit to differentiate them, but really they'd all be clustered around the same place. So some key words to know moving forwards. The axes are what we would call the dimensions of the graph, and each of these points is an embedding. And in Jina, we call all of this stuff the index. Now, what if we want to take this image, a new image, and find something similar? Well, we're humans. We know how to do that, right? Look at the graph. Look at the little picture. Is the new picture a dog or a cat? Is it R or ah? Yeah, it would go about here, very close to the other cute little snowball dog. So yay, we found the closest match. Big whoop. So yeah, I mean, it's just images of cats and dogs, but we understand cats and dogs. We grok cats and dogs. We've seen them everywhere. They're taught to us when we grow up. We get it. Computers don't. So computers, that's all just a bunch of pixels. So we understand the dimensions of cat, dog, cute, ugly, floppy ears, pointy ears, all of those. So we can build our own mental model in our head and embed the pictures into it. In the realm of cats and dogs as well, of course, we can apply things like size. How much do they drool? Are they fierce? Are they friendly? And that way we can get a kind of mental map of all the breeds on an n-dimensional graph. And I say n-dimensional because this could be an arbitrary number of dimensions. In our example, we just used 2. But a lot of the deep learning models will use hundreds of them. It might be cute and ugly, or dog or cat, but we're not telling the computer the dimensions. We're giving it a lot of pictures of cats and a lot of pictures of dogs, and then training it on that. So it builds its own giant mental model that looks like an n-dimensional graph. But we don't know what the axes are, but it does the job. So it's very difficult to show on a screen or conceptualize, of course. Dang it. One of the cool new features that we have in one of our products, Dockeray, is it does generate a 3D animated graph. So you can see things all spinning around. Joe, can you share the thing from Slack on Twitter later? And then we can send it to the group, because that is so cool to see. It gives you a really good understanding of what I'm talking about. Yeah, so that is, in a sense, neural search, using neural networks, aka deep learning models, to build these graphs of data based on similarity and put the different pieces of information where they should be on the graph. So the advantages of this is that it's semantic. If you give it a picture, well, if you give a computer a picture of a dog and ask it to process it without a neural net, it's going to look at how many pixels there are, what color the pixels are, things like that, which isn't really the point of a cat or a dog. But by using a deep neural network, the model understands what a cat or a dog is, or at least what it looks like. So there's a semantic understanding there. It can work with all data types as well, as long as there's a model that can process that data type, and there are thousands of models out there, then Jina can work with it. Well, I'll talk about what data types we can work with a bit later. And one of the other advantages of using Jina is all of these models that are out there, typically you'd have to, they all work a little bit differently. So you'd have to write lots of boilerplate code and integration and glue code to try to get them to fit in your neural search if you were building it from scratch. But with Jina, we have something called Jina Hub. Let me find that, which has all of this stuff available out of the box, and you can integrate it into a Jina app with one line of code. So when I said, I know a few things about AI, but I'm not a pro, this is a big factor in that, because I don't need to know all of that stuff. I don't need to build my own models. I don't need to, even if I did build it, I wouldn't have to put in a lot of work to integrate it, because all of this stuff is available out of the box. And a lot of this stuff is like cutting edge stuff that's been developed by Google or Facebook or Hugging Face. So yeah, you can be lazy and not have to learn stuff, like me. All right. So the challenges of building all of this stuff on your own, of course, is you don't get the plug and play stuff, but then actually deploying it, because, oh man, machine learning stuff can be a bit of a nightmare in terms of infrastructure, because package A depends on TensorFlow 1.1, package B depends on TensorFlow 2.3. I don't use TensorFlow, I'm just pulling numbers out of the air right now. But yeah, you try to run those in the same environment, they are not going to play ball well at all. And then, as you build a more and more complex thing, you're going to get more of these dependency clashes, and it's just a nightmare. Jina solves that. We run a lot of stuff in Docker. So it's all sandboxed in its own little playpen. And it's all optimized to work well together. So I need to change this slide. Reading out a corporate mission statement is kind of dull. The keywords, open source, neural search, all kinds of data. So as I said, all kinds of data, and I mean it. We can do text, images, audio, video. We had a demo a while ago of 3D mesh search, so you could upload a 3D model and find similar ones. We need to get that demo up and running again. And one of our community members built a search engine for amino acid search, or rather built the code for it. We haven't deployed it yet. If anyone here is a molecular biologist or knows one, let us know, because we want to know how good these search results are, because it's beautiful and it looks cool, but none of us know if it's any good. So Jina just relies on three basic concepts. First up is a document. Anything that goes in and comes out of Jina is a document. And a document can be any kind of data. And when I'm talking about document, I'm talking about document with a capital D. So it's Gina's own primitive data type. Or rather, it's a new data library now that we span out called docArray. So yeah, docArray is kind of like JSON, but for intensive compute, like NumPy, like pandas, but it's specifically designed to shine where some of these things don't. So that's being used by Gina's neural search framework. It's being used by one of our other products, Finetuner, and it's available for anyone out there to use because everything we do is, I mean, docArray, Gina neural search framework, and the current version of Finetuner are all totally free and open source to use. That's at docArray.gina.ai. So once you've got a document, you want to do stuff to it. It's like, let's say I want to search through, I can never remember Bronte's books. Emma? I'm hoping, correct me in the chat if anyone knows literature. I think Emma is one of the Bronte books that I had to read in school. So you wouldn't, if you want to find a line matching close to a certain phrase in that book, well, first of all, you'd want to break the book down into phrases so you have something to compare with, because otherwise you're trying to take the meaning of a phrase and compare it to the meaning of the whole book. And those can be very different things. So that would involve like breaking it down into sentences or paragraphs or chapters. So like segmenting it. And then each of these things you break it down into, say sentences. You'd want to encode that. You'd want to put it on the graph we talked about, depending on how happy or sad the sentence is, or traditional or novel it is, for example. Would it be said by an old person or a young person? And then we want to build that index, take all of these points, put them in one place, store that in memory, in a database, on disk, wherever. So an executor, you'd use a different executor to perform each of these three simple tasks. And that's what executors do. Do one thing, do it well. And then, of course, you want to combine these executors to push documents from one to another. And that's where the flow comes in. So the flow lets you streamline and distribute executors. It lets you run executors on your own machine, on the cloud, in Docker, on bare metal, wherever you want. And you can run them in parallel as well to speed up compute-heavy operations like, say, encoding, which often needs a GPU. So yeah, just three simple things: document, executor, flow. I'm a real Linux geek. I've been using Linux as long as I can remember. So I think of it a lot like using Bash or ZSH or CSH if you're into that. So if I ran this on the command line, it would take a file called document, push it through the cutter, which would cut it up into sentences, push it through the encoder, which would encode it into vectors on a graph, and then push it into the indexer, which would build the indexer. Just a standard Bash thing with pipes to pipe things along. In Jina, this would be done with the following code. So it would just be add for the executors that acts as a pipe, and then you open the flow. And you push the documents to index, and then you open up a RESTful interface. So that would let you then search through the documents that you indexed via, well, a REST API. But that's not all, because with Jina Hub that I showed you before, it's also kind of like apt-get. You can really easily use cool new things that you don't have to build yourself. So yeah, you can just, with one line of code, you can use a cool new encoder. And we'll be using Jina Hub extensively in this workshop, because like I said, I'm lazy and I don't know much. So yeah, just to recap Hub, where are we? Yeah, Hub stores all of these components. I mentioned segmenting. Boom, we've got that, sentence sizer. I mentioned encoding. We've got things like transformer torch encoder, which is great for text, or clip, which is cutting edge stuff for images. And then indexing, we've got PQ Lite, which is our own indexer, which is really nice. We've got on-disk storage. We've got stuff for videos. We've got stuff for ranking search results. All of this free to use, simple to use. Yes. Okay, back to the slideshow. So yeah, in short, Jina lets you build a neural search engine with just a few lines of code. Our demo today is probably well under 100 lines. You can search any kind of data as long as there is a model for it. You know, if you're searching for the meaning of life or for true love, maybe Jina isn't your best bet, but you know, if you're searching for data, that's where we shine. It lets you scale it up well for deployment. Obviously, today we're doing a notebook, which isn't really meant for deployment. It's meant for workshops and demos and data science, but yeah, adjusting it to make it something really deployable is very straightforward, and we've got a version I can show you that is deployed. 3 simple concepts, like I said, and you can use existing models or integrate your own. So yeah, with that being said, we'll move on to the workshop. If there are any questions so far, I'm happy to answer them. I don't see any, so that's good, or not. Right, so here we have our notebook. This is running in Google Colab. So yeah, if you have a Google account, you can use this for free. Basically, it's all just Python, but running in your web browser. So we're all running on the same environment, and you don't have to install anything on your machine, except a web browser, which I would assume you already have. This probably won't work on mobile. I've never tried it. I'm not into that level of pain. So Joe, if you could share the link, that would be great.
Yeah.
Is the text size okay? Can everyone see this fine? If not, say in the chat.
The size is good.
Okay,
but can you
cool.
like zoom it a little bit?
Okay. Right. Better?
Yeah.
Cool. All right. So the thing we're building in this workshop is quite similar to one of our examples at examples.gina.ai. We've got a lot of cool examples here. Well, I say they're cool. I built them. I don't think I'm the best judge. But they all have Streamlit front ends because, as I said, I don't know much. And what I don't know includes a lot of CSS and JavaScript. So Streamlit is a nice Python front-end library for data science. So in our meme search, we have 2 options. We can search text or image. The workshop today will just focus on text. So we could type in something straightforward like SpongeBob, and we would get SpongeBob related memes. So some of these directly mention SpongeBob, and some of them mention words like Squidward, which that's where the neural network is coming in. It can't find any more things that have the word SpongeBob, but it knows Squidward is pretty close, so it's returning things based on that. Or we could search something more complex, like Winnie the Pooh food. Okay, these are not good results. I should really test results before I type in things. So yeah, let's not look at those. It is a silly thing. But yeah, if you want to play with it, go to examples.gina.ai. So yeah, we won't be building the front end, and we won't be indexing a lot of data. So it's not going to have the same quality results. But other than that, under the hood, it's pretty much all the same. Except, you know, a few little things missed out because we're running it in a notebook. But we're using the exact same neural network model in this as we are in the version I just showed you. So a quick bit of terminology I'm going to dump on you yet again. So we've got a meme here. So there are some things to know about the meme. The template is surprised koala, and memes only work because they have a template, because you recognize this meme as one in a series of other surprised koala memes. otherwise it's not a meme. The caption, this is poisonous. What? The URI, this is from a data set I found on Kaggle full of image flip memes. Text, which I generated by combining the template and the caption name and the caption. And this text is what we will be searching through. So we're not actually searching the image. So if I type in, well, if I type in eucalyptus, which is what a koala eats, it's not going to be looking at the image and see any eucalyptus in here. But it will know that eucalyptus is related to koalas, and it'll find that this piece of text, like koala here, and yeah, return these memes. Just so we're clear. If you want to build an image-based search engine, all the code is, where is it? It's on my repo somewhere, but I think it's also available. Yeah, you can go to the repo here. Oh no, that's a different example. You can go to the repo here. Yes, this one. So yeah, that's the version you can download, you can deploy, you can run it with Docker Compose. It all works nice, or it should all work nice in theory. Your mileage may vary. Cool, all right. So with that out of the way, we'll do some basic setup. So since we're running in Colab, we don't really need to worry about cleaning up the stuff from last time because Colab doesn't maintain state. If you create a file in Colab today and then close the notebook and come back tomorrow, that file's gone. But this is useful if you're running in, say, Jupyter Lab, which is another really cool notebook environment that runs on your own machine. And this notebook, if you download from the repo, you can just open it in Jupyter Lab. We're going to do some stuff. We're going to enable it in the notebook so we get nice progress bars. And we're going to ignore the warnings because who has time for that kind of stuff? We're just going to look at 50 memes because that'll keep it really quick. Indexing stuff can take a lot of time, though I'll talk later about how long it took to index 200,000 memes, which is what I showed you earlier on the real search engine. But for now, we'll just set it to 50, just so we get an idea. And we'll install a few things, like, well, just Gina. I think that's all we need to install. I think this is installed already. So this is a very recent version of Gina. So everything you see here is like really up to date. Installing always takes time, but we're done. So next up, we need to process the data because with any data science thing, processing data is different every time. And it's a pain in the neck every time as well, frankly. But the data set we chose is from Kaggle, which is a great place for downloading data sets. It's this image flip one. I chose this because it has really rich metadata, like that title, that template text, a link to the actual image. So I don't need to download the image. I can just link to it. And yeah, that's exactly what I want out of a data set. A lot, and the memes are recognizable. Like we've got the Buzz and Woody meme here, which most people are familiar with, and they're not always horribly offensive. Okay, when I searched that Winnie the Pooh thing, some of the results were a bit, but they weren't, you know, racist or sexist or evil in any way, as far as and I looked up all the bad words that I could think of, and that was not something that made me happy, but it's something I did to make sure they were not in that data set, because as we know, the internet is full of horrible people, and they will try to use great power irresponsibly, let's say. Back to the notebook. Oh, and the notebook's under Creative Commons license 0, so you can download it, do whatever the heck you like with it. Yep. Any data set is going to suck in part because it's a product of its time. So you might not have the latest Denkist memes. That's just the nature of data science. So let's download that big old JSON file into a directory called data, just using basic Unix commands here because it takes too long to write it in Python. And yeah, next up, we'll write a function to load the data. And every data set you load is going to have a different data loader function because every data set has different field names and it's arranged differently in a file. Often with quite simple data sets like CSV files, Excel files, simple JSON files, text files, and just a folder of files of, say, images, Jina has some helper functions. So you could do a document array from files and then give it a directory name and a glob, like all the JPEGs from this directory. Or you could say a document array from CSV. So that would just go through and take every document, every line of CSV and turn it into a document. But because our JSON file is a little bit complex, this one, in fact, and quite big, well, I mean, big doesn't matter, complex matters. We can't just do it with a simple function. It's too hinky, too weird. So don't worry too much about this. But what we're going to do is create a document array to hold the documents using the docArray package I talked about earlier. So I mentioned documents before. So any kind of data that goes in or out of Jina is a document. And a document array is just a collection of these documents with a few little helper functions, but you know, it's basically like a Python list for documents. So yeah, we'll look at shuffling the memes, and I'll tell you why we want to do that later. Create a document for each meme, set document text to the template name, surprise koala, and the caption, this is poisonous what. And then we'll populate some metadata, like the absolute URL for the image. So we don't have to worry about storing the image ourselves. We can just look at the link to the image and see the image in our browser. So yeah, we'll run this. And yeah, we'll give it the input file, data memes JSON, set max docs, as I said, to 50. And this time, no shuffle. I forgot to do the import. There we go. And yeah, if you're in a notebook, hitting Shift-Enter executes the cell, goes to the next one. It means a lot less clicking around. Let's try that. Processing, done. Okay, I'm just going to download a little helper file that shows the images in the notebook. If you're building something to deploy, you wouldn't even need this, but it's good to show you what things look like. So this is the first 5 memes we've got. Great, all Drake. So this would be a really boring data set to search. It'd just be a Drake meme search engine, which, I mean, hey, whatever floats your boat, but it's not going to set the world on fire. NFTs do that for us. Okay, so taking a look at the structure of a document, we can see it has several things in it, the ID, the MIME type, tags, and text. And let's just look at each of these. So ID is always unique. The text, as I said before, is a combination of template name and the caption text. So my mom, when I play with my phone for 30 minutes, my mom, when I play with my phone for 30 minutes. I don't know why that's Trump. I just don't get, maybe I'm too old for memes. Okay, the MIME type is a JPEG, obviously. No, it's text plain because, of course, we're searching the text. I shouldn't say obviously so much. And then we've got the tags. So this is the metadata. So caption text, hash, ID. So that's the hash of the ID, I guess. I don't know what that is. I don't care. A template name. This is the ID from the file, not the ID that Gina is giving it. The absolute URI. So if we click that, it should open the image. Yep. The text we set, and this image URL was a field in the JSON file. I think it's a stupid field because it doesn't have any protocol. So you can't just open that easily. But hey, anyway, so it looks a bit rubbish if we don't shuffle them. So let's shuffle them with shuffle true. And now we'll see them. Okay, so now we've got a good selection. The most interesting man, Hard Luck Harold, Sad Harold, whatever his name is. Yeah, we've got 5 different things. So now that we know we've got quite a good randomized data set, and now that we've loaded our data into a document array, we can set up our flow. And as I said before, a flow is, well, a flow performs a high-level task. So if you're building a search engine, you have 2 main big tasks. Indexing, so taking all the data you've got, all of these memes, and building an index out of them. And then querying. So that would be taking a new piece of text and comparing that to all the other documents in your index, and then returning the most similar documents. Like when I searched for Winnie the Pooh and got Winnie the Pooh back. So from Gina import flow, and in the flow, we've got these executors. So I said before, an executor performs a simple low-level task. It does one thing and it does it well. So I mentioned before breaking text down into sentences, but our text is really short, so can't be bothered. So we're just going to encode it directly using, well, when I first did this, I used Transformers torch encoder. So if any of you are familiar with deep learning, you've probably heard of Transformers, you've probably heard of torch. And Transformers comes from Hugging Face, has hundreds of different models you can use with it. I initially used that. It took hours and hours to index 200,000 memes. I tried switching to Spacey just for a test using their medium-sized English language model. It took 4 minutes to index 200,000 memes and gave me good results. So I know what I'm going with. So we're using it from Gina Hub. We're not writing it ourselves, and it'll install it into the Notebooks Python environment, or your own virtual environment if you run this on your own machine. And after that, we're taking those encodings and the metadata from earlier, so all of those document tags like the URI, the URL for the image, and we're building them into an index and storing that. In this case, we're storing it on disk. So we're doing that with Simple Indexer. Both of these are available on Gina Hub. So if you're going to build something yourself, I would now recommend PQ Lite Indexer. That's had a lot more love and it has a lot more power, and it's just as simple to use. But in this example, because I wrote it some time ago, we're using Simple Indexer. So we'll set that up. It doesn't do anything. It just creates the flow, and then we run it through a context manager. So as I said, a search engine has 2 main tasks: index the data and search the data. So first up, we're going to use the index endpoint of the flow. Now, we can use any endpoint you want. Index and search, which we'll use later, are just shortcuts. So you can use Gina for more than just building a neural search engine. Like you could use it for multimedia processing if you wanted, but we specialize in search engines, hence these 2 shortcuts. So we're going to index the documents. We're going to send it the documents we created earlier that don't yet have the embeddings, they don't yet have the meaning attached. We're going to send them in 64 at a time. Since there are only 50, it'll just be done in one shot. We'll see the progress and we'll return the results. And we want to return the results so I can show you what the index looks like, or what a document in the index looks like later. And then we'll just say done. So this bit can take a while because it has to download all of this stuff from Jina Hub. And sometimes Google Colab is a bit buggy. It works fine in Jupyter, so this is definitely a Google issue. But I think it's going to crash. Come on, crash, 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 crash. Well, halt. Yes, runtime failed to start. Hello, runtime failed to start, my old friend. So what we have to do now is restart it and run all cells again. And this is an unpredictable bug. Well, mostly unpredictable. I never quite know what causes it, but restarting always fixes it. Okay, so I think we've still got our saved state. Yeah, we've still got all the data and stuff. But what's it doing? Why is it? Okay, it's running everything. Cool. Doing exactly what we wanted it to do now. And if this doesn't work this time, this is on Google, not me. Yay, it's working. Just when I was going to enable my favorite settings. Ooh, power level. If you go away learning nothing else, now you've learned how to put corgis and kittens in your Google Colab.
Okay, how did you get that? I also want.
Tools, settings, miscellaneous, corgi mode, kitty mode. Always comes back to the cute animals. Okay, I'm going to turn them off because otherwise I'm just going to be staring at them all day. Sorry, folks, party's over. Okay, so now, oh, it ran all the cells. Okay. So now we can look at the embedding for, what the? Okay, my browser's haunted. Ignore the kittens and puppies. So now we can dig into the index documents. There's a lot of metadata there, so it is buried a little deep, but we can see some stuff now. The embedding is what we're looking at. So the embedding is the representation of the data that the deep learning model understands. So based on the meaning of the text, not just the letters and stuff in the text. So yeah, this is an example of what some embedding looks like. And it's pretty long, completely meaningless to us. Oh, where are we? Come back, come back, come back. Yeah, and all of this is stored as a NumPy array. And it's, if the shape is 300, I guess that means it's 300 dimensional. Yeah, so that's our index. We've got 50 memes in our index now with all the embeddings we need. Now we'll put in a search term, say school, just as a quick test to see how well it does. And then we'll wrap that in a document because, as I said, everything that goes in and comes out of Jina is a document. And we'll send that document to the flow. And search endpoint this time. Again, we want to return results so we can see what we get. So that's already been run. Now we'll extract the matches because again, they can be buried a little deep in the JSON that's returned because there's a whole bunch of metadata alongside it. And let's look at the images to see how well our little search did on 50 images. On 50 text strings rather, but we get the images back. So if we look at school, my uncle's diploma says he graduated from a school of fine farts. Well, we got the word school right in there, so that's a win. First woman president, shirts arrive Monday. I don't see any connection there. Maybe that's because we didn't index enough data and it couldn't draw enough connections. Or maybe it's a problem with the model. Or maybe this is deeply somehow about school, but I'm too dumb to understand why. Or maybe because it's a kid dancing and kid, school, they go together. Anyway, it's not a straightforward connection, that one. This one, Picard, blah, 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 college, MIT, Harvard, that's definitely school related. Number 4 freaks me out a bit because I'm a human and I read this text, and this is like a very much school situation. Walked up to a girl sitting at a 2-chair table and asked if the seat was taken. Blah, blah, blah. The fact that the model somehow gets that it's school related, freaks me out a bit. Or maybe it's just the template name just has the word kid or baby in it, and it's making the connection based on that. But either way, weird. And then when your parents take your phone, this isn't a great match, I think, because we used a very small data set of only 50 images. So there aren't many strong connections it can make. But like parents, parents have kids, kids go to school. So there's a connection of a sort. If we use a bigger data set, we can go back to the meme search and just school. Yeah, school. Okay, maybe the image URL in the data set is dead here. School, graduating, school. Yeah, and another galaxy brain one. So all of these are relevant. So if you do it with a bigger data set and the same model and the same everything else, it'll deliver quality results. Right. So yeah, there we have it. We built a search engine very quickly. If you were going to do this in real life, don't use a notebook if you're trying to deploy something in the real world. So I would do this as a standalone thing, usually writing it in my editor and then hosting it somewhere on the cloud. So in a case like that, I would want to use a RESTful API, which is what, the industry standard for APIs. I didn't use it here because we're already running in a web browser, and running REST in a web browser is, I don't know, it's just an extra layer of complication I don't want. So we use the gRPC gateway here in the notebook. The way you would do it with, the RESTful API is just like this, very similar. And we also support WebSockets, though I've never personally used it. We can use Dockerized containers. So instead of Jina Hub, blah, 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 Jina Hub plus Docker, blah, blah, blah. So this sandboxes everything. So if there are dependency clashes, they won't interfere with each other. They'll have their own little playpens. Or you can wrap everything in Docker. Like in the repo, I have a Docker compose file that just deploys everything with one command. And the other thing you might want to do is improve your model by fine-tuning it. So to do that, we have Gina Fine-Tuner. Because the model we're using, CLIP, image encoder, is very general purpose. It's great for all kinds of images. So it doesn't specialize in memes. So if you wanted to train a model specializing in memes, you would tune it just with a meme data set. And you can use Fine-Tuner to do that, to tune it. We've got some examples here at finetuner.gina.ai. So that is the search engine, done and dusted. I'll just go back to the deck and share the last few slides.
Meanwhile, can you, sorry to stop you there. So there are like 1 or 2 questions. So
Sure.
Can you check Q&A?
All right. Open questions. Okay, I'm seeing one from Kanak. I hope I'm saying your name right. So during training our model, the normal old way, we had to resize the images to make sure they're the same size and perform normalization and all that. Do we need to do that with Jina as well, or it takes care of everything? So I would do that in the doc array. So doc array, what are we? So doc array has some cool functions that let you do all that stuff. So here we are. So in my data loader, I used some slightly out of date methods, but the new doc array lets you do simple image processing directly. So first of all, you could load the image load the URI to an image tensor, and then you can set the shape, normalize it, change the channel axis. And these are all the things you'd want to do if you're trying to fine tune a PyTorch model or working with data in PyTorch. Yeah, you can also display a sprite of all the images in your data set all at once, segment images into smaller ones, and do we have the plot? I'm hoping we have the animation, plot, visualization. Do we have it? Summary and table, embedding projector, yeah. So you can get an image like this. Well, I mean, hell, practically a whole app in your web browser like this. It'll let you zoom in and see where on a three-dimensional graph, so it's simplified, but see where all the images are in relation to each other. And that'll give you an idea of if your model is fine-tuned or not. Yeah, I hope that answers the question. In the code for section, Dockerized executes platform agnostic. It works really well on Linux and Mac. Windows, we support Windows to an extent. I'm not sure. If you want to use Jina on Windows, use WSL2, Windows Subsystem for Linux version 2. Just Google WSL2 for info on that. Because just running it on plain vanilla Windows isn't going to work well. But yeah, Dockerized executors. So if you go to docs.jina.ai, where are we? Install Jina on Windows. So yeah, compatibility of executors in the hub. So they might not be compatible to run natively on Windows. Some of them do, some of them don't. I'll say that. And that's the best I can give you. Because we're relying on a lot of third-party libraries, like Spacey, like Transformers, like whatever the heck Clip uses, like PyTorch, like TensorFlow. So if they don't work on Windows, that particular executor won't work on Windows either. But everything else should work fine. And if it doesn't, you can let us know on Slack. Cool. Are there any more questions? Good questions, by the way. All right. So back to it. So yeah, next steps. If you want to get started learning Jina, you can go to learn.jina.ai. If you want to read up more on the docs, we have docs.jina.ai and now docarray.jina.ai for docarray and finetuner.jina.ai just for finetuner. We will be putting some notebooks up on our blog related to Dockeray and Finetuner over the next week or so. So keep an eye on jina.ai/blog. Yeah, but we'll have more in the next week or so. And we are moving towards doing a lot more notebooks. So instead of just normal blog posts, you're going to be able to play with the code, run the code in your browser, really get hands-on and dirty with it. Hands-on and get your hands dirty with it. All right. I'd like to take the opportunity to invite you to our Engineering All Hands event. So we run these every month. We get guest speakers in, we get speakers from Gina ourselves, talking about what's new in machine learning or in neural search, or with Gina or Docker or Finetuner specifically. Our community can ask questions. There'll be engineering tips. It's the second Tuesday of every month, about 4 p.m. CET. So what's that in EST? Well, time, buddy. "4 p.m. CET is about 10 a.m. EST. So about this time. We're also going to be looking at running some other events, so keep an eye on the Gina blog for those. Joe and some of our other colleagues are cooking up something for Women's Day, and we'll have more info on that soon, hopefully.
Yep.
And yeah, last but not least, you can find our repo at get.gina.ai. We'd love a star, we'd love a fork. So yeah, if you can, please do. You can join our community at slack.gina.ai. We're very friendly. We're always here to help. We don't bite hard. Yeah, we're on LinkedIn, we're on Twitter, we're on YouTube, not on TikTok yet, but if you have a Gina dance that you want to do, I'm sure we can set up a TikTok account especially just for that. Yeah, that's pretty
By
much
the
it.
way,
Oh,
since you mentioned Gina dance, so in Bollywood, yeah, in Bollywood you have a lot of songs that begin with Gina, or they have the word Gina in it, and I don't know how many times I've been teased about them. Lollywood too, yeah.
okay, so that's the new task for Team India.
So we have, by the way, we have the swag form link finally. Would you like to also talk about a bit about Learning Portal? I mean, they could
sure.
try it.
So our Learning Portal
That's the coolest thing.
is a learn.gina.ai. So this tells you everything you need to know. So what is neural search? You can experience demos, install Gina. And for all of these, you can take quizzes. And if you take a quiz and you pass, you'll get a certificate. You can share it on Twitter, on LinkedIn, wherever you like, to show that you really do know what you're talking about with Gina. So yeah, and if you have any feedback for this, hey, let us know, because this is new for us. We only got it out a month or two ago. So yeah, we're excited for people to use this.
So yeah, that is like the coolest thing. It's like a boot camp which you can have for learning Gina. And if you have any doubts on the way, you have encounter problems, there's always Slack, on which our team is like super responsive. And yeah, I don't think so we get off Slack. So yeah, you could try that. And I shared the form, the swag form in the chat. You can fill that up. And for any questions, again, you could just DM Alex on Slack. You can just, in our support channel, you can just drop in. And
don't DM me. Don't slip into my DMs.
Yeah, I slipped that.
Support, because then we can share the love and share the knowledge.
Yeah, so chances are basically if you DM one person, he might be offline and there will be delays. So just go public, go on Slack and just share your whatever you are building or whatever the problems that you're having.
Yeah, like I said, we're friendly. We answer a lot of questions. If you have an issue, put it on our GitHub issues. Cool. All right.
Yes, Runjhun,
anything else?
Runjhun can take.
Any final questions?
Yeah.
All right, I guess that's a wrap. Thanks, everyone. It's been a blast.
Thank you so much, Alex. I mean, everything was very well, organized, and you gave us a very good search engine to make, and we are excited to be, in that zone. And make our own search engine. And I hope everybody will be sharing their innovative ideas as well. Let's start off with the wrap up slide. Can you stop sharing? I can share mine.
Sure. Whoa, chat just exploded.
Yep. It was exploring for a long time, you know. When you were
Especially when you
talking.
showed us the kitty one, the kitty,
Yeah.
you know, yeah, we love
That's something
that.
I don't know.
Okay, so these are our upcoming events. The first one was today, and it went, I think, very well. Thanks to Alex, thanks to Jyoti. We have upcoming events on 3rd of Feb and on 10th of Feb as well. We have a collaboration event with Accenture India on 3rd of Feb. So do check it out. And lastly, thank you, everybody. Thank you, Alex. Thank you, Jyoti. I mean, it was very, very good to know you and, take this collaboration forward. I'm hoping we have more events coming up with this collab. And thank you so much. Any ending thoughts?
Always excited to do more events. And yeah, thanks for coming, everyone. Like I said, I had a blast.
Same here. I mean, especially for the people who are doing it like really late, because it's 10:40. So, thank you so much for staying for so long, and especially like joining in.
It's 10:40. Whoa, thy name is Joe.
So just a heads up, the recording will be provided to you on Slack. I think we posted it in a day or two on our YouTube channel, so you can check that out. If you have any doubts, you can always contact Alex, Jyoti, Zarreen, or me anytime on Slack. We have all the links in the chat, and I think we'll be closing now. Thanks to the audience for coming and taking our time doing hands-on session. It was so fun to chat with you all, and this is the swag form. Please do check this out. I'm sure there's many good things coming your way. Just fill the form, do all the hands-on, and Jyoti will be dispatching all your swags very soon. Thank you, everybody. Thanks for your time.
Thanks, everyone. Bye-bye.
Bye.
Stay safe.